Hey guys, Josh McKay with the Test Experts doing more calculus today. Today we're talking about implicit differentiation. Implicit differentiation is where you take the derivative of two things and, when you take the derivative of something without respect to that variable. So usually when we're taking derivatives up to this point, we've been taking derivative of y with respect to x, so we're taking dy dx of some function. So let me erase that. Here we're taking derivative with respect to x, but we've got a y in the function. How do we deal with that? We take the derivative normally, so the derivative of 0 is still 0. The derivative of x is 1. And the derivative of y, do it as if it was just we're taking the derivative of this variable. So the derivative of y would be 1. But since we're taking the derivative with respect to x, then we've also got to multiply that by the derivative of y, which is dy dx. So the next thing here you need to do is solve this for dy dx, because usually the question will say something like what is y prime or what is dy dx. Also, some people will write in y prime here instead of dy dx. Either way is acceptable. So I'm trying to solve this for dy dx. All I need to do is really subtract 1 over. So as you can probably see, this is dy dx equals -1, and that would be the final answer. This next implicit differentiation problem is a little more difficult, but we're going to approach it the same way. So again, just take the derivative of one thing at a time using the rules you know. If you take a derivative of y, throw in either a y prime or a dy dx. So derivative of x is just 1. Derivative of 3y, or y cubed, would be 3y squared, but because it's a y, I'm going to say times y prime. Again, some people use dy dx. Next, the derivative of this term is minus 4y, again times y prime, and the derivative of 5 is 0, so I'm not going to write anything. Now, what we've got to do is we've got to get y prime by itself. So this is where it gets a little tricky sometimes. What you need to do is factor out y prime. So I'm going to have 1 equals, I'm going to put y prime out front, times 3y squared minus 4y. All right, again, the entire purpose is to get y prime by itself. So I need to now divide this over to the other side. So the final answer will be y prime equals 1 over 3y squared minus 4y. For the next implicit differentiation question, we have for the function y squared equals 3x squared plus 2x, find dy dt when x equals 2 and dx dt equals 3. Now this is interesting. Remember again, what's on the bottom here is what matters. And I said at the beginning, we use implicit when this bottom function doesn't match the variables here. So because it's dt on the bottom, dy dt, we're actually going to have to do implicit differentiation both on the y variable and the x variable. So let's start by taking the derivative. The derivative of y squared would be 2y. Again, because that's not the bottom variable t, we have to throw in a y prime, or a dy dt. The derivative of 3x squared is 6x. Now, this is where it gets tricky because usually you're not used to throwing in an x prime, but because this is a t, we've got to do the x prime here. And then finally plus 2, again we took a derivative with respect to x, so we got to throw in an x prime there. Okay, now, in the previous videos, as soon as we take this derivative, we start solving for y prime. And that's not wrong here, but it's much easier when you've been given x and dx dt to immediately go plug in. Another thing we need, so we've got our x prime, we're going to start just plugging those in, but we're missing our y. So what do? We need to plug this 2 back into the original function to solve for y. So if I plug in here, I've got y squared equals 3 x squared, which is 2, plus 2 times 2. So I'm going to get y squared equals, that's 12 plus 4, y squared equals 16, so y equals plus or minus 4. In this case, I'm only going to use the positive y as we plug back in. But there's probably actually two solutions to this problem. Use both the positive and the negative. So I've got 2 times 4 times y prime equals 6 times my x was 2. These are all givens. My x prime is 3 plus 2 times x prime again, which was 3. And then I've got all numbers in, solve for y prime. And the point I was trying to make earlier is you could solve for y prime first, but why? If you can get numbers in, your algebra, your math becomes much easier than dealing with variables. So get the numbers in as soon as you can, and now it'll be much easier to solve y prime. We've got 8 y prime equals 36 plus 6 is 42. So y prime will be 42 over 8, and reduce that fraction. That's it. If you like today's video, give us the thumbs up, subscribe to our channel with follow on and with notifications on, and comment on the video if you liked it.